You now know how to use the internal EEPROM, but since it's only 1 kilobyte in size, you may wonder what you can do in order to store more data. You may remember from the SD card lecture that SD cards is a good way to store lots of data persistently. However, the SD card module is a bit pricey. You can get one for about $2 to $10 depending on its bells and whistles. And then you still need to add the cost of and the size of the SD card itself, which is over $5, plus the complexity of using the card itself. An external EEPROM is a good alternative. You can get a 256 kilobyte external EEPROM for around $1.50. Store a lot more data in it as compared to the internal capacity, and you only need a tiny amount of space on your printed circuit board. Let's check this out. I'm using the Atmel 24C256 chip, which provides 256 kilobytes of EEPROM memory. It communicates with the Arduino via I2C, which is great. You can connect several chips if your memory needs grow. The module I purchased on eBay also makes it easy to change the device address by bridging the pins marked A0, A1, and A2. So this is the external EEPROM. It's got a 256,000 byte memory on this, and this is the chip. This array of pins allow you to change the I2C address, where the slave address that this device will be listening to. I'm going to wire it up first, and then I'm going to show you how to detect what address the device is listening to by default, because I'm not really sure what it is myself. It didn't come with the documentation. So first I'm going to wire it up, and then I'm going to detect its default address. So make things a little bit easier, I've got this jumper wire. I'm going to just connect its header like that, and I'm going to plug that in my breadboard like this. Now I can see here that I've got VCC on the blue wire, SCL, which is the grey one, SDA is the orange wire, and ground is the red wire. I might do it the other way around, so I don't have ground being the red wire. I don't want to do the wrong connections, because in my mind red is always VCC. Okay, so red is now VCC, so I'm going to use another red wire to connect that to the Arduino 5 volts. Ground, sorry, I already made a mistake. Let's turn this around as well, so that we've got red going to red. Okay, so now the ground, which is this one here, goes the ground on the Arduino. I'm going to use a green wire for SCL. SCL goes onto analog pin 5 on the Arduino, just like here. And finally a blue wire for SDA. It's going to be analog pin 4. Right, so here's my connections. A nice red light. It's promising, nothing's burned. So just leave that aside here for now. So I've got this sketch. It's called the I2C scanner. Don't worry too much about what's inside. I'm just going to execute it, and then it will go through 127 possible I2C addresses on the Arduino bus, and then tell me in the monitor if it's detected any device on the bus. And yep, it says that it did find a device at address 50. So this is a default address that the EEPROM device is listening to. I'm going to use it in my sketch in a minute. So I can get rid of this now. Don't need it anymore. So with the wirings completed, let's have a look at this sketch. Now, in my sketch I'm including the wire library since we need to communicate with the device using I2C. Then I've got an inclusion of this library called EEPROM, or EEPROM, External EEPROM library, which is a library that I created a few days ago. So I was researching this lecture. I found some code online that did exactly the reading and writing that I needed to do on the external EEPROM, but the problem was that it wasn't packaged in a library, so you had to copy and paste all of the code and the functions in the main sketch. It's not a very user-friendly or reusable way of using your code. So I went ahead and turned this into a library. I've got more information about this in the notes, and I'm also going to create a little lecture later on to explain in a few simple steps how to create your own libraries. But the point is that this is where your library is, and it exposes a few simple functions, like this one, for example. If you want to write a byte or a page, or to read a byte or a buffer, which basically means multiple bytes. So this is the library that we are using. I'm going to create an object out of it. This is a constructor. Then inside the setup function, I define an array of chars, of characters that I'm going to store in the EEPROM first and then read out of the EEPROM. Now the actual reading happens here. So I call the I2C underscore EEPROM underscore write underscore page function of my EEPROM object. The first parameter is the address of the device, the I2C address of the device, 50, which is what the scanner gave us earlier. The second parameter is the EEPROM address. So this is the address where the block of data that I'd like to write will begin. So the first address is going to be 0. Then I'm passing a pointer to the array of chars, and finally the size of the data block that I want to store. So I'm using the size of function, passing the array name to it, and this will return the number of characters that this array contains. Wait for a few milliseconds, or wait for 10 milliseconds, and then we're done. In the loop, I'm going to, well, don't worry about that, I'm going to go and grab the first byte. So I have to read one byte at a time now. So I'm going to use my I2C EEPROM underscore read underscore byte function of the EEPROM object. Always need to pass the I2C address of the device, and I'm starting to read back byte by byte, starting at address 0. So put that in B. So there's the byte B. For as long as B is not 0, so as long as there's more characters to read, I haven't reached the end of the array, then print out the character representation of this byte, increment the address of the EEPROM by 1, and read the next byte. And do that for as long as you have not reached the end of the array of chars. So once you do, you get out of this block and the script finishes. Actually, it doesn't finish. You wait for another 2 seconds and then do the whole thing again. So let's execute it and make sure that it works. Okay, so written the data in the EEPROM, and then this is the output of the reading. Every 2 seconds it will go and read the EEPROM address. Try to be as frugal as possible when using EEPROM. These memories have a limited lifespan, usually around 100,000 read-write cycles. This is indeed a large number. However, if you do reading and writing in a loop, like when storing sensor log data every few seconds, you could wear it out before you know it. In general, it is a really bad idea to put write calls to the EEPROM in a loop, as it is possible to burn out those bytes in a few minutes. There is a big reason behind only playing with the EEPROM inside the setup loop in the demos of this lecture, never inside the loop function.